The beauty of truth tables and these logical statements is they are also applied in digital logic used in all forms of computers and electrical circuitry. They can also be applied in organizational logistics that manage such things as transportation, warehousing, even inventory. This is a simple example of electrical circuitry that you might find in your own home. So for example, suppose you have a light that lights up a stairway. You may have a light switch at the bottom of the stairs that operates the light. Then you may have another switch at the top of the stairs that operates the same light. And then finally, you may have a third switch that operates the same light. These are known as three-way switches. If the switches are all in the on position, that's when the light is illuminated. Then when any of these switches changes position, that changes the current status of whether the light is illuminated or not. So if we have these three switches and we can label them P, Q, and R, similar to what we've done for regular statements, then I can make the standard values for each one of these switches. As we've done in the past, I'm going to go ahead and fill in the truth values. The first half will be true, and the second half will be false. We then take that same pattern and half it. And then we just alternate it for the last one. Now, if we assume that when all the switches are in the on position, then we could say that the on position is true. So here's the on position. All three are in the on position. So that means that the light is illuminated. It's on. Then as soon as one of the switches changes from the current status here of on, that means it's going to turn it off. So when they're all on, when they're all true, I should say, then it's on. When one of them changes, then it's off. If the current status where they're all in the true and it switches, like this one right here, then it goes to off. So if we're currently off right here, true, false, true, then when one of the switches changes, it goes back to on. So we could see a pattern develop: on, off, off, on. If true, true, true is all on, then when we switch one of them, or in other words, you could think of it as negating it, turns it off. If this is the off position, then changing one of the switches turns it back on. Again, if this is the off position, then changing one of the switches turns it on. And if this is an on position, then changing one of the switches turns it off. And as you observe, we have on, off, off, on, and then we have a mirror image of off, on, off. And there you go.